Okay, so start of a new topic. This is all about trig graphs. What do I mean by trig graphs? That is how functions in the form of y equals sine x, cos x, or tan x look on the graph. So before we begin, just a couple of definitions, things to be aware of when we're looking at these graphs. Start off with, I've got amplitude. So the amplitude of a trigonometric function is the distance from the middle point to the highest/lowest. So you'll see what I mean about that in just a second when I start drawing one. And the other one is the period. So the period of a trigonometric function is the minimum interval, or how long it takes for a function to repeat its pattern. And that's because our trig functions, they sort of repeat their pattern going off to infinity and also back to negative infinity. So we want to see how long it takes before that pattern repeats itself. So let's jump straight to it. To start off with, our sine function. So our sine function, to begin with, on my upper axes, I've got y equals sine x in the intervals of 0 is less than or equal to x, which is less than or equal to 360. And this is just to give us a nice little snapshot of how it moves within these 360 degrees. So I start off at 0. And then I curve up around to the 90 degrees, which I then curve back down to the 180. From there, I pass through into the negative to 270. And from there, I curve back to the 360 degrees. And as you can see, I have a maximum point of 1 and a minimum point of -1. So if we were to look to see how that moves on my one lower down. So this is sort of a set of axes, imagining going off to infinity. So that's my first wave that I've just done to that 360 degree mark. And then essentially it just repeats itself. So at that point there, it would be 720, 1080, and so forth. It just keeps happening again and again, going on and on forever. And it does the same thing in reverse. So that there would be minus 360, minus 720, minus 1080, and so forth. So we can see it takes that full 360 degrees before it then repeats doing the same pattern again and again. So that means my period is going to be 360 degrees. And my amplitude, remember that's the distance from the midpoint to the highest and to the lowest. So that's a distance of 1 and that's a distance of 1. So that means my amplitude is 1. And I always think one way to sort of remember how the sine graph kind of moves is how the wave is drawn between the 0 and the 360 degrees. It kind of looks like an S on its side. So I think sine, my wave is going to look like an S for sine. Okay, let's take a look at our cosine function. So same idea, looking between the 0 to 360. This one is actually quite similar to our sine, but it's got one little difference that occurs. So this time, I'm going to start at 1. And then I curve to 0 at 90. And then I begin to start curving back when I hit the 180. Then back through the 270. And then it curves back with a maximum at that 360 mark. So again, if I was to look to see how that looks like on a larger set of axes. So that's my cosine wave. And then it just happens again and again. And it just keeps going. And same in reverse. So it just keeps happening. And so looking at the period, we can see here, again, it's after that 360 degrees, it then repeats doing the same thing again and again. So our period is going to be 360 degrees again. And so our amplitude, so our middle point to the highest point, that is 1. And same down here, going to my lowest point, that is also 1. So that means my amplitude is still 1. And I think one way to sort of imagine the difference between the sine wave and the cosine wave is I always think of Pharrell Williams, 'cause I'm happy, do 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 do, because you know it's like a smiley face, hey, you know, little happy face. So always think 'cause I'm happy, and that will be one way to try and help remember the cosine wave. All right. So then our last function then is the tangent. Now this is just the one where it's a bit weird. So what happens is starts at 0, then it shoots off to infinity. And then at about 90 degrees, an error occurs, and suddenly after 90 degrees, it reappears at negative infinity. Curves to hit 0 at 180. And then shoots back off to infinity, then reappears back down at negative infinity to hit 360 at 0. So let's take a look at what I've just drawn on a larger scale. So it goes off and up. So that's what I've drawn so far. And if I was to continue that, it just kind of keeps repeating the same thing, this sort of slanted kind of shape again and again. And it also does it backwards as well. Like so. Now, my period this time, I can see this sort of like shape occurs across every 180 degrees. So that means this time, my period is going to be 180 degrees. And my amplitude, because I go off to infinity, that means my amplitude is going to be infinite. Okay. So let's just take a look at a couple of questions where we have to use these graphs. So to start off with, let's take a look. Write the following in order of size, starting with the smallest. So I've got cos 90, cos 100, and cos 300. So I want to put them in order from smallest to largest. So to begin with, I'm going to quickly draw out my cosine wave to help me. So I think cos I'm happy, so I draw my little smiley face. 1 minus 1, and where it passes through was at 90 degrees and the 270. So I want to identify where the cos 90, cos 100, and cos 300 sits. So my cos 90 is there, so it's at 0. My 100 is going to be just a little bit afterwards, so it's not going to be too far. And then my cos 300, that's going to be after the 270, so it's going to be somewhere up there. So that means my smallest is going to be this one here, which was the cos 100. And then my next smallest is at 0 with the cos 90. And then my last one is going to be the cos 300. So let's take a look at one more example like that. So this time I'm dealing with the sine wave. So I'm going to draw it out. And I remember, yep, my sine wave is the one where the S is on its side. And remember, it passes through there at 180 and here at 360. So I'd mark roughly where all the things are. So I've got the sine 180 to deal with. My sine 90, that was at the top of my curve. Sine 100, so that's going to be somewhere after it. And the sine 200, that's somewhere after the 180. So my smallest is going to be this one here with the sine 200. My next smallest is bang on the 180. Then my next one is going to be that sine 100. And my last one's going to be that sine 90 at the top. So that was an introduction to trig graphs. Now, The main feature of this topic is what we can do to slightly change and transform these trig graphs, and that's what's going to be covered in the next few videos. So let me know if you have any questions, and good luck with the work.